Alright guys, this is the next video on linear functions. So we're getting into a bit of the harder sort of algebra type stuff, sort of maths methods type stuff. You should have done this maths anyway in year 10. If you don't remember, well, you better get up to scratch pretty quick, alright? As you might have seen in the previous video, I had some difficulty drawing a straight line using this program. And yeah, it's often very difficult and inaccurate finding variables in a graph relying on a line you've drawn, because you're going to have inaccuracies through the thickness of the pencil, your ruling ability, that sort of thing. So it's always going to be more exact to describe linear relationship between two variables when you use a linear function instead of just drawing the graph. So from previous years, you should have seen that straight lines with a gradient represented by the variable m, and a y-intercept represented by the variable c, can be represented with the equation y is equal to mx plus c. M would be replaced by what the gradient is, and the c would be replaced by wherever the y-intercept is. So y is equal to mx plus c is the linear function that fully describes the relationship between x and y coordinates on a straight line. Any straight line can be represented in an equation that looks exactly like that. If it doesn't look like that, then it's not going to be a straight line. You can use that function algebraically to find the value of any of the two variables as long as you know the other one. So let's run through an example here of working out the equation based on a line that you're given. So the graph below shows the relationship between the height of a candle, y millimeters, and the time it has been lit for in hours, x hours. So it's often helpful with these questions to think about the scenario and before you've even looked at the equations or anything, understand what you should be seeing happen. If you light a candle, it slowly melts away. So it's not getting taller, it's getting shorter. So what we should see is a graph that's showing that the candle is getting shorter as time goes by. And that's what you can see here, because this y-axis is the height, this x-axis is the time. Obviously the independent variable, the one that's being changed on purpose, is causing the candle to get shorter and shorter over time. So now we get to the algebra part. We need to use the graph to help us find A, what is the linear function connecting x and y? A. So I've told you the linear function in any straight line is going to be y is equal to mx plus c. We need to find what m is. M is the gradient, and we've said that the gradient is the difference between the y-coordinates of 2 points divided by the difference between the x coordinate of 2 points. So we need 2 points here. Let's do this. That's point 1, and this will be point 2. So point 2's y-coordinate, if we go across like that and go down, point 2's y-coordinate is 50. And the point 1's y-coordinate is 90, because it's up here at 90, crosses the y-axis at 90. The x-coordinate of point 2 is 10, and the x-coordinate of point 1 is 0. So 50 take 90 is going to be negative 40. 10 take 0 is going to be 10, so it's going to be negative 4 gradient. And that makes sense. The slope is going down. It's going down and to the right, so it's a negative slope. C, pretty easy. Here we can see where the y-axis is crossed. It's crossed at 90. So now that we know the gradient and y-intercept, and you've been told that the linear function, m stands for the gradient and c stands for the y-intercept, we can work out what the linear function for this line is. Therefore, y is equal to negative 4, because that's what the gradient is, x, plus the y-intercept, which is 90. So that is the linear function for this straight line in the question. So answering B. Now we can use algebra instead of using drawn lines to work out answers. Use a linear function to find the height of the candle after 12 hours. So we know the relationship between the y-axis, which is the height of the candle, and the x-axis, which is the time in hours, is y is equal to negative 4x plus 90. We want to know the height of the candle after 12 hours. So X is representing the time in hours. So all you need to do is substitute 12 into that, because X is in hours, the X-axis in hours. So that -4 times by 12 is -48 plus 90. -48 plus 90 is going to be 42. So therefore, the candle will be 42 millimeters, because that's the units of the y-axis, after 12 hours. Alright, and C, how long will it take for the candle to burn out completely? So a fully burned out candle, we're assuming, is a height of 0. We know the linear relationship is this, y is equal to -4x plus 90. So now we're trying to work out what x is. But we know what the y is that we're talking about, because it's a burnt out candle. So y is going to be 0 here. So we need to use algebra to rearrange and work out what x is. So I need x on one side, so I need to get rid of this plus 90 on the right side. To get rid of plus 90, you need to take 90. But because it's algebra, you need to take 90 from both sides. And so you'll have -90 equals -4x. And then x is going to be -90 divided by -4. Running out of space here. And then if you put that in your calculator, x is going to be, if you work out -90 divided by -4, it's going to be positive 22.5. So that's telling you that candle will reach 0 millimeters, burn out, at 22.5 hours that it's been left burning. Alright, so that's an example of using a linear function to find exact answers to questions. Hopefully that helps you out, and I'll see you in the next video.